This is Math 95, Section 7.3. We are going to be simplifying radical expressions in this section. For this first movie, we're just going to develop the product rule and the quotient rule for radicals. We will work on simplifying radicals in the next several videos. So first we want to develop our product rule like we've done for our exponents. So ignore the non-English at the bottom of the page. I first want to look at something like the square root of 9 times the square root of 4. What we can do is we can call this, the square root of 9 is 3, square root of 4 is 2, and 3 times 2 is 6. Really straightforward. Another way we could look at this is we could multiply our 9 times 4 inside the radical and get the square root of 36, which is also 6. So what we say for the product rule is I can multiply before I simplify inside or after. It shouldn't matter. It shouldn't matter if I first do my multiplication and then simplify my radical, or simplify my radicals and then multiply. So I should be able to split them apart or push them together. And that's what this is saying. I can put two radicals with the same index together, or I can split a radical that's having multiplication inside of it into two separate radicals. So to use that property really quick, the general rule is if they're split apart, push them together. So the first one I want to look at is this square root of 2 times the square root of 7. And we need to ask ourselves, can I simplify either of these as they stand right now? Can I do anything to the square root of 2? Can I do anything to the square root of 7? And I can't. They're both irrational numbers. So then I'm going to stick them under the same radical, and I wind up with the square root of 14. And that doesn't break down either, so that right there is my final answer. We're not doing anything to that. Same thing with my 17 times y. I can't do anything to either one of those as they stand now, so I'm going to slide them under the same radical and go have some lunch or something. We're done with that one. If I scroll down a little bit, now I have the cube root of 2 times the cube root of 32. And as it stands right here, I can't do anything with that 2, so I am going to multiply these together. And put them under the same radical, I get the cube root of 2 times 32. Now at this point, I don't know if I can do anything with this. I could multiply the 64, but maybe off the top of my head I don't know what the cube root of 64 is. So instead what I'm going to do is I'm going to just write a factor tree for that 32. So 32, to get all of its factors, maybe I've got a 4 times an 8. And that 4 is a 2 times a 2. And that 8 is a 2 times a 4, which is a 2 times a 2. And then I'm going to, that's not what I wanted. I'm going to circle all of my primes. So 32 is really 2 to the 5th power. So back to my radical, I really have the cube root of 2 times 2 to the 5th. Using my rules of exponents, I know that that's a 2 to the 6th power. So I'm looking to simplify the cube root of 2 to the 6th. But we can use the rational exponents we talked about earlier, turn this into 2 to the 6 thirds, which is 2 squared, which is 4. Now, all of this is kind of intermediate steps. You could have known that the cube root of 64 is 4, and you didn't necessarily have to show all of this. This is the background story. This is what's really going on in the background, and so I wanted to write it all the way out here with all of the steps. But now for something like this, I'm going to make use of rules of fractions, and I'm going to slide all of these together. And I'm going to multiply straight across. Put the 2 in front, because that's standard notation. And then I'm going to look and see if I can simplify any of this, and the answer is no, I cannot. So this one now is also finished. So now I want to talk about the quotient rule. Again, we're going to build the rule that we have for ourselves. I would like to look at the square root of 100, which is 10, over the square root of 25, which is 5, and 10 over 5 is 2. Alternatively, I could take my 100 divided by 25 under the radical and get the square root of 4, which is also 2. So the quotient rule says, again, as long as my index matches, and of course our denominator is not 0, then if I have two things divided, I can split them apart, or I can put them together under the same radical, as long as the base matches. Sorry, as long as the index matches. So, let's practice that really quick. So, fairly straightforward at the beginning. Square root of 9 is 3. Square root of 25 is 5. If you can do that without your calculator, it's fine to do so. If you wanted to show work, you could show me this is the square root of 3 squared over the square root of 5 squared, something like that. That's fine for work. On something like this, I can visualize you knowing how to do that in your head. It's not very much of a stretch. But for something like this, I would like to see you break it into the square root of y over the square root of 36, perhaps? Because what's the square root of y? We don't know, so we're going to call it the square root of y. And then you can take the square root of 36 and get a 6. And just have that be your final answer. For cube roots, instead of looking for squares, so pairs of things, we're actually going to look for cubes of things. So you may recall, perhaps, that 27 is 3 cubed, and 64, we just did this, was 4 cubed, and I'm taking the cube root of both of these. So to show what I'm doing, I like to split it up. And then I can sort of show that the index and the power cancel each other out, leaving me with a 3 over 4. So what about something like this? I think I am going to group these things together. Can I fit them all together up here? Oh, I can. That's fancy. We're gonna go with a divider bar there. And now I can work with this guy. Okay. Just make sure this is still readable for all of you. So I'm looking for the fifth root of 7 over 32x to the fifth. And my first step is going to be to break this into pieces. So I want to turn this into the fifth root of 7 over the fifth root of 32 times the fifth root of x to the fifth. And this will allow me to deal with each piece individually. So, is there something that multiplies by itself 5 times to get 7? Well, yes there is, but it's not a nice pretty whole number. So we're going to keep this as a 5th root of 7. But this 32, just did this on a couple slides ago, the 32 is 2 to the 5th power. So I'm going to rewrite it that way. And then in the denominator I also have the 5th root of x to the 5th. I'm just going to keep writing that down. So you may find it helpful to write this with rational exponents. I'm going to leave the 7 in here because it doesn't simplify. But we might like to think of this as 2 to the 5/5 and x to the 5/5. And if I do that, then that cancels to a 1 and that cancels to a 1. And my final answer is the 5th root of 7 over 2x. And that would be how something like this simplifies. And it's not pretty anymore. And that's okay. Alright, so in the next videos, we are just going to start simplifying some of the longer looking radical expressions. So go ahead and take a look at those.